Hey everyone, we're going to take an intro into the formulas we're going to use to solve some of our sequences and model them. So let's take a look at this sequence. This is similar to what we did in class today. We have the sequence 3, 5, 7, 9. Now if you're looking at this and you kind of figure out what we did today, you know that this is an arithmetic sequence. And you know that because we're going up 2 each time, so it's just an addition of 2. That's our change from one number to the next. If we're looking for the next 3 terms, we probably want to do this by just adding 2, adding 2, adding 2. So there's definitely formulas we can use there, but if you think about it in the most basic sense, if you know that you're adding 2 for each term to get the next term, you want to just add 2 from 9 to get to 11, add 2 from 11 to get to 13, add 2 from 13 to get to 15. So, relating this to function notation. Now this is going to be our opening discussion tomorrow. So, think about this as we go through this lesson. So as I kind of continue with this presentation, think about how this relates to function notation. Come in ready to discuss. I hope to have a good discussion on that. I hope everyone comes up with some ideas there so we can have a little back and forth with that, as well as with what's going on during this little lesson. So if I'm saying that the first term that I see is 3, and I'm going to call that f of 1, what would f of 0 be? So if this is what I'm calling term 1, 2, 3, 4, 5, 6, 7, and so on, term 0 is the one that comes first. It's the initial term. When we think of initial, it's basically our starting point. So this is term 0. If we're adding 2 to go up, we just subtract 2 to go back. So f of 0, or our original or our initial term, would be 1. Okay, you do that by taking the number that you started with and going back if you're given the first term. So let's look at some of our formulas. These are the explicit formulas. Explicit formulas help you do one thing. Find far away term values. So say I'm given the first 5 terms of a sequence and I want the 60th. This is a great way to do it, using the explicit formula. So say I'm given, for an arithmetic sequence, f of n equals d times n plus f of 0. You're probably looking at this and say, I have no idea what any of that means. But that's what I'm here for. So f of n is the value of term n. So we don't know what n is. N is just the term number. So if I said I want the 20th term, that would be n equals 20. F of 0 is what we just talked about, the initial term. Basically our starting point. F of 0 is our initial value, like before when we said something with our function rules was our initial value. That's something we all need to think about. D in this is the common difference. We talked about that today. So in an arithmetic, D, common difference, times n, the term number, plus the initial term will give you your value of your term far away. For a geometric sequence, which is the one where we're using multiplication, again, f of n is still the value of term n. F of 0 is still our initial term. N is still our term number. Notice this time it's a power. And R, as we learned today, is our common ratio. And that's the number that you're multiplying by each time. So basically, you can find the 58th term of a geometric sequence by saying the initial term times the common ratio to the 58th power is your value of your 58th term. So list the ages of a child up to age 5. This is a good way to kind of figure out how these work. So as you're born, you have to be age 0. Okay, you're not born at age 1. So that's why when we talk about f of 0 being our initial term, that's what we mean. It's our starting point. So 0, 1, 2, 3, 4, 5, and so on and so forth. Write a rule that represents the ages in a person's lifetime. So, let's see, would this be explicit or recursive? Well, we haven't learned recursive yet, so it's going to be explicit. Is it arithmetic or geometric? Since we're adding, it's going to be arithmetic. So let's say, in our last formula, we have f of n equals d times n plus f of 0. So our 0th term in this one is 0, right? You start at 0 years old. Our common difference is clearly 1. We don't know what n is. N could be any number that we want to find. So this is what our equation is going to look like. It's going to be f of n equals 1n plus 0, but it's really just f of n equals 1n because 0, your initial value, does not have to be added on. It's the additive identity. So the recursive formulas. These are a little more complicated to look at, but very easy to work with. So what we're saying here, f of n again, term value of term n. F of n minus 1 is the term value of the previous term. D is still the common difference. And what this is saying is that n has to be greater than 1. So you can't have a previous term unless you've had a term before it. And when saying f of 1 equals k, it's just whatever value f of 1 is equal to. So this is the value of f of 1. So when we actually apply this, you'll be given a k there. For a geometric, very similar. F of n, still the term value for term n. F of n minus 1 is still the term value of the previous term. R is still your common ratio. N greater than 1, okay, same situation. And f of 1 still equals k, still the value of your first term. Alright, so it's not the initial term, it's f of 1, your first term. So let's look at this sequence. 5, 10, 15, 20. And we're given that f of 3 equals 5. So what would f of 2 be then? We'd have to move backwards. And since it looks like we're adding 5 each time, we just subtract 5 and get 0. What is f of 4? Well, if f of 3 is 5, the next term, 10, is f of 4. And you did that recursively, whether you realized it or not. The term before was 5, so the term after it, okay, is 10. So what you're saying here is f of 4 equals f of 4 minus 1 plus the common difference. And we know that term 4 equals term 3 plus 5, since we're going up 5 each time. So f of 4 equals 5 plus 5, which is 10. So you did this in your head recursively, I did it in my head recursively, but this is how you would use the formula. So let's write the recursive rule off of that. You would say that f of n equals f of n minus 1 plus 5, since we're adding 5 each time. And we're going to say n greater than 1, and f of 1 would equal, well, if f of 2 equals 0, f of 1 would be negative 5. So f of 0, our initial term, would be negative 10. But since we're restricting our domain to all n values greater than 1, we want to start with f of 1. Okay, so it's f of n equals f of n minus 1 plus 5, where n is greater than 1 and f of 1 equals negative 5. So come in tomorrow ready to apply these skills and discuss how this relates to function notation.